In this video, we're going to dive into the Any method in LINQ. The Any method is a versatile tool for checking if any elements in a collection meet a certain condition or simply exist. It's like asking, is there at least one element in this collection that follows the rule we set? Or, in some cases, does this collection contain any elements at all? The Any method can give us a straightforward answer, a Boolean value. It returns true if at least one element in the collection passes the test, or if the collection is not empty, and false otherwise. Here's the interesting part. Any comes in two flavors. The first one checks whether the sequence contains any elements. It's great for quickly verifying if a collection is empty or not. It's very simple, the method after the sequence we want to check. The second overload applies a lambda expression or a small function that tests each item against a rule. If this function finds at least one item that says yes, or true, then any returns true. In summary, the first overload simply checks for the presence of any elements in the collection, while the second overload checks for elements that meet a specific condition. So, that's the essence of the Any method. Simple yet powerful, and applicable in a wide array of scenarios. We will be exploring these through practical examples using arrays, lists, and other data types. Let's see Any method in action. I have the following array of integers. I want to find out if this array has at least one even number. Let's see how to do that in two different ways using both overloads of Any method. First, let's use the Any method without a condition like this, which means that the first overload of the method is used. What we are doing here is first filtering the array with the where method. This method picks out just the even numbers from our array. Here's the result of where method. Then, we use any to check if this new collection of even numbers has any items in it. If it does, any returns true. Since our array does have even numbers, any will return true, indicating the collection is not empty. In other words, we are checking if the array contains even numbers. True means, it contains even numbers. Now, let's see the second way. This time, we are using the Any method with a condition. Here, the lambda expression inside any checks each number in the array to see if it's even. The Any method then returns true or false, depending on whether it finds any even numbers. In our case, since the array includes even numbers, the result will be true. And that's how you can use both overloads of the Any method to query an array of integers. The first method is a two-step process where we filter first and then check, while the second method combines these steps into one. Let's delve into another example using the Any method with a data table. Imagine we have a table filled with various products. Our objective is to check if there are any products in the electronics category that are priced above 700. Here's how we approach this. In our query, we utilize the second overload of the Any method. The condition we set comprises two parts. Firstly, we filter to get only the rows that belong to the electronics category. Secondly, we check if any of these products have a price exceeding 700. When we look at our data, the first row itself presents an electronic product priced at 800. This satisfies our condition, resulting in the query returning true. This demonstrates how the Any method can effectively determine the presence of specific conditions within a category. Now, let's examine a different scenario with the same data table. Suppose we want to extract an array of strings, each representing a product category where at least one product is priced below 100. Here's the query for this requirement. We start by grouping the rows based on the category column. This results in the following three groups, where each group contains the rows of the same category. In our where clause, the condition is set using the second overload of the Any method. This condition checks if any product in the group is priced under 100. Following this check, we select the category names in case the condition is true. Finally, we apply the toArray method to convert our result into an array of strings. The outcome is an array containing categories that meet our criteria. In this case, we have two categories, each with at least one product priced below 100. This example illustrates the versatility of the Any method. It's not just for obtaining a Boolean result, it can also be used within a query to filter and manipulate data, producing varied outputs like an array of strings. In this section, after exploring the usage of both overloads of the Any method, we now turn our attention to comparing the all and any methods in LINQ. We will consider their purpose, return values, behavior with an empty collection, and typical use cases. The purpose of the 𝗨 method is to determine whether all elements in a collection satisfy a specified condition. It returns true if every element in the collection meets this condition, but it will return false if even a single element does not. An interesting aspect of the 𝗨 method is its behavior with an empty collection. It returns true. This outcome is based on the principle of vacuous truth in logic, meaning that since there are no elements to contradict the condition is considered to be met by default. The 𝗨 method is typically used when you need to ensure that every item in a collection adheres to a rule or standard, such as verifying that all numbers in a list are positive. In contrast, the purpose of the any method is to check if any, at least one, element in a collection satisfies a specified condition. The any method returns true if at least one element in the collection meets the condition. However, if none of the elements meet the condition, or if the collection is empty, it returns false. Notably, with an empty collection, any always returns false because there are no elements available to meet the condition. You would typically use any when you want to verify the existence of elements in a collection that meet a certain criterion, such as checking if a list contains any negative numbers. Despite these differences, 𝗨 and any share some similarities. Both are LINQ methods used to check conditions on collections in a concise and readable manner. They both can take a lambda expression as a predicate, to specify the condition to be checked against the elements of the collection. Moreover, both methods return a Boolean value, true or false, based on whether the elements of the collection meet the given condition. Having discussed the differences and similarities between the 𝗨 and any methods, it's also important to consider their performance implications, particularly in large collections. In a previous video, we discussed the performance aspects of the 𝗨 method, highlighting its efficiency in processing large datasets. To quickly summarize, the key advantage of 𝗨 lies in its early exit feature. The method stops processing as soon as it encounters the first element that does not meet the specified condition. This behavior is particularly useful in large collections, as it saves time and resources by preventing unnecessary checks on remaining elements. Now, let's talk about the performance of the any method. Similar to 𝗨, any also boasts an early exit capability, but it functions in the opposite scenario. Any ceases its evaluation the moment it finds an element that satisfies the condition. This is especially efficient when such an element is located early in a large collection. The method then avoids the extra overhead of traversing through the entire dataset, leading to faster execution times. So, whether you're confirming that all elements meet a certain standard with 𝗨, or searching for at least one that does with any, both methods offer performance efficiencies that can be critical in handling extensive data. As we conclude this video, I encourage you to apply these concepts in your own projects. The best way to truly grasp the power and efficiency of LINQ, and particularly methods like 𝗨 and any, is through practical application. Experiment with them, integrate them into your code, and observe how they can optimize your data processing tasks. It's in the real-world usage that these methods reveal their true potential. Remember, practice is the key to mastering any programming concept. So, go ahead, use these methods in your next project, and watch your proficiency with LINQ grow.